Hey everyone, in this video we are going to talk about section 3.1b, which again is about the mean value theorem. We're just going to continue on with one more example, so enjoy.
So here we are given the interval 3 to 7, and we're given our function f of x is equal to 3x squared minus 2x plus 5. First thing we're going to do is we're going to find the secant line from x equals 3 to x equals 7. So basically, okay, I'm going to just sketch out this graph. It's not going to be great. That's fine, I just want an idea. Okay, I know it's a parabola, I know it's opening up, I know it has a y-intercept of 5, so it might look something like this. Beautiful, good job, Miss Dolans. Okay, and then I know that our interval that we are looking at is 3 to 7. Okay, so, I don't know, here's 3, here's 7. So, first thing we are going to do is we're going to find this equation of this secant line. Okay, so that's easy. We need a point on the line and we need a slope. And we're going to use the average slope to find this. So here we go, our slope. Well, that's stuff that we learned in like Algebra 1. It's f of, let's see, we have our closed interval, 3, 7, closed interval, there we go, nice. Okay, AB, so it's f of 7 minus f of 3 over 7 minus 3. Okay, I've already gone ahead and I have evaluated these for you. If you don't believe me, you can go back and do it. F of 7 is going to be 138, and f of 3 is 26. Neat. Okay, so now we have 138 minus 26 over 3. Okay, well, that's going to be 112. Whoa. I already got ahead of myself. Hopefully you found my mistake. This should have been a 3. So here we should have a 4. I think I caught that. Okay, so that should be 112 over 4, and that's going to give us 28. So I know that the slope of this line is 28. And okay, so since we are finding a secant line, we're always going to use point slope to do this. It's just easier. We don't actually have to simplify it. So point slope form, okay, we're going to have y equals 28 times, okay, we can choose either of these. I'll write both lines for us because why not? It's 28 times x minus 7 plus 138. Here's our first one. Or we could also have the line y equals 28 times x minus 3 plus 26. Here's our second one. Either one is fine. You don't need to simplify. Just leave it in point slope form. You don't want to lose any points for simplifying and making a stupid error. Alright, okay, for B, we're going to find the tangent line parallel to the secant line in the open interval 3, 7. Alright, so what's that meaning? So we're going to find a line that is parallel to this, and that is touching or tangent to a point on this. So really what this is saying is, hey, find the value of C that satisfies the mean value theorem. Satisfies mean value theorem. Alright, well we can do that. Okay, so just because I'm going to add to our visual, here's the point that we are trying to find. It's tangent. I want to find the equation of this line. Okay, so first of all, that means that we need to find C. So for B, we're really trying to figure out where f prime, or the slope, is equal to 28. So, okay, we need to find the derivative of this. So, okay, f prime of x, well, this is just going to be a power rule. Okay, that's going to be 6x minus 2. So we're trying to see where 6x minus 2 is equal to 28. So solving for that, okay, add 2 both sides. 6x equals 30, so x equals 5. So hey, what that means right here is that this value that we found is 5. And in our mean value theorem, this is what we call C. So really C is equal to 5. Alright, so we know the slope, we know the x value, let's just find our y value. I've already gone ahead and did that for you. I know that f of 5 is equal to 70. Or, okay, we can also write this as a point, that's 570. So writing our equation of our line in point slope form, we have y equals 28. That's our slope of x minus 5 plus 70. Nice. So when in doubt, think about a visual. It always helps me. We're going to look at one more problem real quick. It's kind of a non-traditional problem. It says the Kansas Turnpike decides to stop using highway patrolmen to stop speeders. So, okay, Kansas Turnpike, that's that private highway that could take you to like K-State. So it's the toll road, you need a K-tag for it, or you just need to pay the toll. So instead of using patrolmen, they're just going to use those toll booths to write tickets. So suppose that they find a 120-mile trip was completed in an hour and 30 minutes. So we're going to explain why they can write a ticket. Okay, well, we're going to use the mean value theorem for this. Surprise, surprise. And now you're probably shocked. Okay, so remember our mean value theorem says that we're trying to find the average rate of change, and we're saying that's going to be equal to the instantaneous rate of change. Okay, well, let's find our average speed. So our average speed, okay, that was a 120-mile trip. And it looks like we completed it in 1.5 hours. So our average speed of this trip was 80 miles per hour. So because of the mean value theorem, it says that somewhere on this trip, our average rate of change had to be equal to the instantaneous rate of change. Well, since our average rate of change was 80 miles per hour, that means that somewhere you were speeding. We're going to assume that this was 70, 75, the normal speed limit. Somewhere on that trip, your instantaneous rate of change was also 80 miles per hour. Okay, we're just going to write a quick little blurb here just to kind of summarize all of this. So let's say, first of all, okay, we use the mean value theorem for this. So let's just say that it satisfied the initial conditions. So because speed is a differentiable and continuous function, because it's differential and continuous, the mean value theorem applies. So that means that there must be at least one point So at least, oh, that was a big jump, that's fine. At least one point in time where the average speed equals the instantaneous speed. All right, and so at least once the person had to have been driving 80 miles per hour. All right, folks, that's all I have for you today. I'll see you next time.